Hello everyone. Welcome to Controllers Tech. This is another video in the Nextion display series. And today, we will see how to use buttons on the display. How to get the input from the display, and use it to control the LED on the MCU. Let's start with the Nextion Editor first. Create a new project here. I will fast forward through the initial setup. You can check out previous videos if you don't understand it. Now, for the background, I will use a picture. You need to first add the picture to the library, and then select it from here. Now add a button to the display. I am going to add one more. This is button B0, and it will show the text, on. You can modify its look, like change the background color, or text color, anything you want. This is button B1, and the text shown will be, off. Now pay attention to this window here. This is basically touch event, and we can configure what the button should send when we press it. This is the release event. It sends the configured data on the release of the button. I am selecting the component ID to see what it actually sends when we press it. Let's compile this. We got some positioning error. These buttons are a bit out of the display bound. Now everything is fine. Let's debug this. Here you can see, when the button was released, it sent some hexadecimal codes. Here the first byte is start byte, then page number, then button ID, then its value, and then we have the end sequence. Note that, button ID for the on button is 0x02. Similarly, when the off button is released, it sent the same sequence, except the button ID is 0x03. We can work with that default code also, but it's better if we define our own string sequence. First of all, I wanted to send some start character. You can use any start character. Next, it should send the page number. This will be handy when we will work with multiple pages. Next, it should send the button ID. Print S is to indicate that it should send the string format for the button ID. B0 is the button object, ID is the ID, and comma 1 means the ID should be 1 character long. And in the end, we will send some terminating character. I will put the same code in the off button, and make some necessary changes, like change the button object. Let's compile and debug it, to see what output will we get. So here we have the start character, the page number, the button ID, and the end character. You can see the same output from the off button. This type of string format is easier to work with, as we already know what to expect from the buttons. Let's upload this to our Nextion display. I am using the TTL method to upload this code. You can see that the USB to serial device is connected to COM4. I have already shown this in the previous videos. Connections will be as shown in the picture. So, the uploading is done. Now let's go to the Cube IDE and create a project for this. I am using STM32F446RE. First of all, I am selecting external crystal for the main clock. I will connect the display to UART4. Make sure that you select the baud rate of 9600, it won't work with other baud rates. Also enable the interrupt, and in the end, I will show you how can we use interrupt for this entire process. Let's go to the clock setup. I have 8 MHz HSE crystal, and I want the clock to run at maximum frequency. Let's enable the LED also, as we need to toggle it using the buttons. So here is our main file. First of all, I am creating an array to store 4 bytes. I am using 4 bytes because that's what the button is going to send when we press and release it. Now in the while loop, let's receive 4 bytes of data from the UART. I am giving 1 second timeout, in case if the data is not received. This received data will be stored in Rx data array. As you can see the sequence of bytes, first byte is start character, second is page number, and the third byte is the button ID. When I press and release the on button, it sends its ID, which is 2. And the off button's ID is 3. So we will check the third byte in the array. If the third byte is 2, this will turn the LED on. Similarly, if the third byte is 3, it will turn the LED off. Let's build this code. We don't have any errors, so let's flash it. You can see the display have the same background, and the buttons too. When I release the on button, the LED turns on, and when I release the off button, LED turns off. Notice here, that it works with release, and not with the press, as we programmed it to do. Let's go back to our Nextion Editor now. There is one more type of button available, that is, dual state button. Basically, it have 2 different states, on, and off. Let's give some string on this button. Again, we will write the custom code for the touch release event. Object name is BT0. I will keep the start character, and the page number same as earlier. Here again we want the button to send the ID, and along with the ID, it should send the value also. Let's debug it to see the output. As you can see, the button ID is 4, and the value is 1. This means that the button is in state 1. The rest of the values are same as before. If I press it again, it sends a new value, that is 0, indicating its new state. Now our data is 5 bytes long for the dual state button, so I will add some dummy character here too. This way, we will have to only look for 5 bytes, and it will be easier to program the reception. Let's upload the new program to the display. So it's done. Let's go back to the cube IDE now. Resize the array to 5 bytes. I will just add new code to this one. If the button ID is 4, that means the dual state button is pressed. Now we will look for the value. If the value is 0, the LED will turn off, and if the value is 1, the LED will turn on. Let's flash it to the MCU. You can see all 3 buttons working perfectly. As I mentioned in the beginning, I will also show how to use it with the interrupt, so that we don't have to wait for the data to arrive. HAL UART receive IT will use the interrupt to receive the 5 bytes of data. Once the 5 bytes are received, our XComplete callback function will be called, and that's where we will write the rest of the program. Just copy these all operations inside the callback function. Also make sure that you call the receive IT function in the end of the callback. Let's delete it, as it's not needed anymore. You can perform some other operations in the while loop. It's time to build, and flash. You can see the things are working as they should. This is it for the video. I hope you understood it. You can do more with these buttons, like modifying their background, their fonts, or even more. I will leave the link for the code, and the HMI file, in the description. In the next video, we will see some graphics. Goodbye for now. Keep watching, and have a nice day.